Hello viewers, welcome back. So in this tutorial I am going to train my model which we have created in the last tutorial, which is 16. And as data said, I've taken flower data, and you can see there are 5 types of flower out there. So these are the flowers pictures of out there, and I'm going to process these data out there and make a flower.py file and then train my model. So this is my model out there, Vgg16 out there, and I will be saving this model, untrained model, uh, as my Vgg16.h5. So let's see the summary of the model. So let's see the summary. So model.summary, see the summary of the model. And you can see out there, so this is my model out there. So it is a huge model. So I'll be importing the input image is out there is 224 by 224 by 3, and then after layers of convolution and max pooling, the final shape out there is 7 7 and 512 depth out there. So and then I have flattened this, and then I have used some fully connected layers, and the number of neurons I have used is 256 out there, then fully connected layer of 128. And since I have 5 output, that is 5 types of flower, so the last layer I have created with 5 neurons out there. So if I see the trainable parameters out there is 26480,709, so non-trainable parameters is 0. So this is the summary of the model which we have created, that is Vgg16 out there. Now it's time to train the model. For that reason I have to process my data. So to process my data, I have used this Utils.py. If you don't know how to process the data, I will be suggesting one of my videos so that you can make this Utils.py, and I will be giving these Utils.py files GitHub link so that you can download if you don't want to go to that video. Don't worry. So this function out there, make data, will process the data and save this data into features and labels, and flower.pickle file will be as saved. And by using this load data, I'll be loading these features from flower.pickle. So you can see out there it will return features and labels. Okay, fine, let's import this data. So from utils, import load data. So let's load the data. So feature and label, just call this function. Now I want to see, let's write the classes, categories, name of the categories out there. Just I am copying one single line out there. So these are the categories of flower, that is daisy, dandelion, rose, sunflower, tulip out there. Now I want to see some of the flowers. So for give out there, plot dot figure, and give out there fixed size 8 by 8, and here I have to import matplotlib dot pyplot as plot. Okay, now for I in range of 25, plot dot subplot, give out there 5 comma 5 comma I, then plot dot imshow, give out there feature I out there, and plot dot x label, give out there categories, and pass out there the label I out there. Fine. Now plot dot xticks, keep out there blank. Okay. Now plot dot show. So let's see what's the output or get. Okay, I'm getting an error out there. That should be 1. You can see these are the flowers out there and the labels out there. So I didn't shuffle my data, so all the flowers of same type is out there. So let's shuffle my data from sklearn dot model selection import train test state. What I am going to do is with this function is I am going to divide this feature and label into train set and test set. So let's do so. X train out there and X test out there and Y test out there, Y train out there and Y test out there. Just call this function train test split and give out there the feature and the label and give the test size of 10% and give out there shuffle equal to true. By default it's true. You don't have to give this because I am giving this. Now write out there X train and give out there Y train. Fine. Now run the code. So you can see now I am getting the data output into shuffle format, and there is rose out there, tulip out there, rose out there, sunflower out there. So it's shuffle data, and I have made the trace test set and print set. Fine. Now it's time to train my model. So let's input the model. So import TensorFlow STL. Fine. Now I have to do is model equal to tf dot keras dot models dot load model. Now I am going to import my model. So I have saved my model as my Vgg16.h5, and there is another h5 format model out there. So this is the trained model and this is the untrained model. So I am loading this trained model out there for now for the demonstration purpose. Just so my Vgg model dot 5. So my Vgg model dot h5. Fine. And I have to process the data out there. So X train out there and X test out there. Just cast this data. For that reason, tf dot cast and pass out the X train and give out the tf dot float 32 and again tf dot cast, pass out their X test and give out their tf dot float 32. So that now I have to make the train set. So train data set batchable. For that reason, equal to tf dot data dot dataset dot from tensor slices, pass out there the X train and Y train out. Now train dataset equal to train dataset dot batch. Give the batch size out there. So I will be suggesting to give a batch size of smaller. So I will be giving 1. Since it's a large model, yeah, it will require huge GPU power to train this model. So if you have smaller GPU power, then I will be suggesting you to give batch size of lower amount. So I am giving 1. You can give 10, 100 and more if you have a greater GP power. So I have loaded my model and created batchable data set, and it's time to, and model is there. So let's in this model. So loss object. So for loss, I'll be using tf.keras dot losses dot sparse categorical cross entropy. Just making an object, loss object, and optimizer. So as optimizer, I am going to use tf.keras dot optimizers dot ada delta, again creating another object, and train loss equal to tf.keras dot matrix, and use out their mean and pass out there. Okay, you can give a name out there, it's not mandatory, just give a name, train loss, as you wish, or you can keep it blank. And train accuracy equal to tf dot keras dot matrix dot sparse categorical accuracy. Again give a name out there, train accuracy. Okay, fine. Now I am going to make a function, tf dot function. So def define train step and pass out their images and pass out the labels. So with, now I'm going to use gradient tab, tf dot gradient tab as step. Now create the model predictions. So predictions equal to model dot predict, sorry, model, just pass out their images, and training equal to true. Loss out there equal to pass out their train loss. So train loss, oh sorry, loss object out there, loss object out there, and pass out there y true. So as y true, give the labels, and y pred, that is predicted by the model, is predictions. Okay, fine. Now gradients. So gradients equal to step dot gradient and pass out there loss and pass out there model dot trainable variables. Fine. So optimizer dot apply gradients, pass out there grades and variables. Okay, I have to zip this file, trainable variables. Okay, fine. Varies, grades and varies equal to zip this with gradients and model dot trainable parameters. So trainable variables. So what I have done here, you can see I have used gradient tab, so that now then I got the predictions through my model, and here I am calculating the loss for loss object and passing out there the labels, that is true value, and the predicted labels out there for each of the base size, and gradients out there. I'm getting the gradients, that is the slopes out there, by using tab.gradient, and passing out there the loss, that is cost out there, and the trainable parameters out there. And I am using the optimizer to train the model, uh, and pass out there the gradients and trainable parameters. Now all I have to do is train loss out there. So train loss, so that I can see the loss in each of the epoch. Train accuracy, pass out there loss and levels and predictions. So I have created the train step. Now I have to go for each of the epoch. For epoch, in range of uh, for you are now I am going to give the number of epochs of training. So let's get 5 out there. For a large model like Vgg16, 5 epochs is nothing. I'm just giving it for demonstration purpose. So train loss equal to dot reset. So I'm going to reset train loss in each of the epoch. So reset states and train accuracy dot reset states, and step equal to 0 out there. For images and labels in each of the base, so train data set. So this is the data set which I have created and make it batchable. So if you give out there batch size equal to 10, here for each of the loop, here I'll get 10 images and 10 labels out there. Since I have given batch size equal to 1, so I'll get 1 image and 1 label. So if you give small batch size, it will take longer time, and if you give large batch size, it will take less time to train. But if you have less GPU power, you have to give small batch size. So step plus equal 1, and train. Now call this function which I have defined out there, and the purpose of this add tf dot function is to make this function as graph. So train it step, call this, pass out there images and pass out their labels, and if step, so I want to see the accuracy for each of the 10 steps. So print out there epoch percent I out there, then loss out there, give out there percent 0.4f, and accuracy out there, right out there percent 0.4f out there. Here I am going to give epoch plus 1 and pass out there the loss. So train loss dot result, and train accuracy dot result. Okay, fine. Yeah, I'm done. So all I have to do now, save the model again. Model, so save as my Vgg model.h5. So you can train the model now. Here I am giving as changing the number of epochs as 1. Since I have trained the model previously, it will take hours to train you by you, and I have used around 80 epochs to train this model, and now I am getting around 90% accuracy. So let's see and run for one epoch. Yeah, I'm getting a one error out there. So there is the error. Train state from images levels are given. What's the problem? Okay, I got the error. I didn't use bracket out there. So you will get some warning. So you can see out there my training has started, and since I have trained the model previously, and there I am getting training accuracy of 90% around, and loss is about 0.2. So this is how we can train the model. So let's get the prediction now. So create another file, control N, control S, prediction file. Fine. Now all I have to do, just copy up to here, control C, control B. Now here I have to, okay, I have to load the model, control C and control B. So let's get the prediction out there. So let's say I want to have the prediction equal to model and pass out there. uh, okay, I want to pass one of the feature, so feature 1 out there. Okay, I want to pass 10 feature out there. Okay, for I, now let's see the result. For I in range of 10, plot dot subplot, give out there 3 comma 3 comma I plus 1, and pass out there plot dot im show phr out there, and pass out there I plot dot x level, and pass out there predicted predicted so predicted, give out there percent s, then go to the next line, actual actual, again percent s, give out there percent, and here I am going to give the prediction, and I out there, give out there, instead of prediction, give out their categories, and pass out their prediction, pass out their I. Okay, okay, I have to take help of another one. So import numpy as np. Let's see argmax. So numpy dot argmax. So there just put the bracket over there. Okay, fine, it should work fine now. And okay, give a comma over there and give over there another string, that is, come to the next line, categories, pass over there, actual, so labels, label I over there. Here I have to give third bracket, so give third bracket over there, and plot dot xtx, keep out there blank, give a figure size, so plot dot fig size, oh sorry, figure, give out their fig size 8,8, fine. Everything should fine. Let's see the plot. So plot dot show. Okay, let's give out the 9 instead of 10, and here give 9 instead of 10. Okay, see now what I get the result. And you can see out there, this is the predicted result, daisy, 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 daisy out there, and daisy, and dandelion out there predicted as dandelion, daisy, 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 daisy. So, and it's predicted as sunflower, but it's daisy out there. So I didn't shuffle my data, so let's shuffle this data. So for the purpose of shuffling, I am not just use this one from the previous one, and here I am going to give x test, and here everything is fine. Let's give x test, so x test, and here give out their y test. Let's see the result now. So this is the predicted results out there. Dandelion, dandelion, sunflower out there, sunflower predicted as daisy, daisy, tulip, but predicted as tulip, but actually is rose. Dandelion, dandelion, daisy, daisy, tulip, tulip. So this is all for this tutorial, and if you like my effort, please don't forget to subscribe. And in the next tutorial, I'll be training and creating a ResNet model. So this is all. Thanks for watching.